মনত রাখিবা যে Rayleigh-Jean's law, Planck's law, Z law হোক, the formula is this: U nu d nu. U nu to কি? Energy density, per unit energy density in the frequency range nu and nu plus d nu is what this G nu d nu. Itu থাকিবই times energy average. Common formula. Planck's or Carnot, Rayleigh-Jean's or Carnot. It is standard formula. It is কোনো physics মানে ইয়ার specific case নাই. There is nothing specific here. মানে এইটো কি? কিমান খিনি actually তোমার waves আছে? How many standing waves are there in the frequency range between nu and nu plus d nu? You have to count those. So this is the counting part. And this is the energy per such states. So number of states, number of waves, standing waves, times energy of each of those. That's your total energy. Okay? Number of states, this is divided by VSAR. So you can say this is density of states. You can say density of states. This is it. Now the diversion hole, if they ask Rayleigh-Jean's law, then or Planck's law, this is the only thing that differs. So for Rayleigh-Jean's, they consider classical equipartition. So equipartition, what does it say? Tomar blackbody radiation or blackbody wall oscillators আছে. For an oscillator, there are 2 degrees of freedom. And therefore, half kBt plus half kBt, kBt. So you have to put this equal to kBt. And then you put it here, you have Rayleigh-Jean's law. And for Planck, this average is h nu by e to the power h nu by kBt. minus 1. Then you get Planck's law. And G nu d nu value kiman? This is common. 8 pi by c cube nu square d nu. This part is common. Okay. So hey karone tomar Rayleigh-Jean's ki hoy? Energy average of nu nai. Nu kono function nai. Just at a kBt ahi nu square হয়ে যায়. So এটা একটা প্যারাবোলার মেশিন না, এই কারণে আলট্রাভায়োলেট ক্যাটাস্ট্রফি হয়। প্ল্যাঙ্কৰ ফর্মুলা এভারেজ ফর্মুলা এনেকুৱা আছে, মানে তলত এটা e টু দি পাৱাৰ h নিউ আছে, ইয়াতে h নিউ আছে। সো হিটো লাগি কি হয়, এই এটা নিউ আৰু ইয়াত নিউ স্কয়াৰ নিউ কিউ হৈ যায় আৰু তলত এই e টু দি পাৱাৰ থাকে, এই কাৰণে তোমাৰ এনেকুৱা ফাংশনটো আহে। So that's it. So মনত ৰাখিবা this আৰু average energy value for Rayleigh-Jean's and for Planck. দুটা বেলেগ। And this you have to remember always. It's easy to remember actually. Nu square cube. Remember that we took a sphere. How many points inside a sphere? A sphere or surface area, radius or square, 4 pi r square. And radius to কি basically তোমার momentum. So এই কারণে তোমার ইয়াতে এটা নিউ থাকিব, নিউ স্কয়ার হবে, p square. So nu square. This you have to remember, and this you have to remember. Okay. So once again, this, right? This is the Planck's law. Okay. Now, কি কৰিব লাগিব? We can derive a lot of things from this. Everything actually. First one, let's say Rayleigh-Jean's law. Let me still keep it separated. Better. 8 pi c cube nu squared d nu times h nu by e to the power h nu by kb t minus 1. So first, Rayleigh-Jean's law. Remember, Rayleigh-Jean's law exactly what do we need? This should be kBt, right? This part is same. So if we can prove that average becomes kBt, then we are done, right? Energy average, if it becomes like equipartition kBt, then we are done. What is the energy average? This. So let's see if this becomes kBt. In what limit? In Rayleigh-Jean's limit. Rayleigh-Jean's limit is where Rayleigh-Jean's could explain. So they could explain very close to. Remember, this is nu, this is u nu. Rayleigh-Jean's formula was valid here for a very small nu. So we have to take very small nu. Nu should be small, which means this nu should be small. So h nu much less than kBt. Nu should be small, h nu much less than kBt. Okay? Which means temperature बहुत high hole hobo. Okay, put this here. What will happen? This is very small. Right? H nu is very small means e to the power something is very small. So we can expand e and take just one value of like e to the power x is what? 1 plus x square by 2 factorial plus, right? Now if x is very small, then we can just take up to this, right? X is small. Here h nu is very small, so the whole thing is very small. So then what happens to E bar? E bar equal to h nu by e to the power h nu by kb t minus 1 becomes h nu, and here 1 plus h nu by kb t, right? Minus 1 e to the power this I have written as 1 plus h nu by kb t, approximated. It's like this. And minus 1 ase, so minus 1 ase. So minus 1 goal. H nu jabo kBt oporot goi. Which is exactly the average that Rayleigh and Jeans used using equipartition. Right? So that means this Planck's formula becomes exactly like equipartition energy. And so obviously this whole expression will become Rayleigh-Jean's law. Clear, right? Because this part to common ase Planck kora rohe. This part to just kBt ahi gole Rayleigh-Jean's law ahi jabo. So this means, this implies this is Rayleigh-Jean's law, because this expression comes from classical equipartition law. Other extreme. So one extreme is frequency very low. The other extreme is frequency very high, which means this side. So this side match korle this law is what? Rayleigh-Jean's. And this side actually is your Wien's distribution. So this side matches with Wien's distribution, this side with Rayleigh-Jean's. Let's see. So that side means very high frequency, which would mean h nu now much greater than kBt. So not much less than, it's much greater than. And this will give us what? Wien's distribution. Right? Let's see. Ki hobo. Once again, etut to just nu square ase. Nothing is going to change. Let's take this part. So this will become, so if it is very high, h nu much greater than kBt, that means this term is big. So that means e to the power this is much bigger than 1, then I can neglect 1. Right? So h nu by just e to the power h nu by kBt, or h nu e to the power minus h nu by kBt. Right? ওপৰত লৈ গৈছো. That means আমাৰ u nu d nu কিমান হ'ব? 8 pi by c cube. Even constant না লাগে, কারণ Wien's distribution lot গোটে constant তো এটা a নাম দি দিছে. So we'll see. Nu square আছিল, ইয়াত nu square এটা আছে, h nu cube হ'ব, right? Nu square আৰু a nu আছে, h nu cube e to the minus h nu by kBt d nu. Okay? Okay. So আমার কি লাগে? Wavelength আৰু temperature relation লাগিব Wien's distribution or কাৰণে. এইবিলাক h pi 8 এইবিলাক না লাগে, because Wien just এটো a এটা constant নাম দি দিছে. So let's just say proportional to nu cube e to the minus h nu by kBt. Even হয় ঠিক আছে d nu, right? এটাই লাগে আমার. So Wien's distribution look into in terms of আমার কি wavelength, frequency না হয়, right? So take it in terms of wavelength. So here কি হবো? c by lambda. So c cube by lambda cube. We don't care about c, constant. ইয়াত কি হবো? c by এটা ইয়াত lambda থাকিব তলত, ইয়াত কি হবো? c by lambda. So 1 over lambda square এটা আহিব, right? Okay, let's say 1 over lambda ইয়াত, right? So this will become proportional to 1 over lambda cube e to the power blah 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 1 over lambda square d lambda, right? Don't worry about the minus sign. D of 1 over lambda মানে কি? 1 over lambda square d lambda, right? Derivative of 1 over lambda, which just means the frequency arrow lambda inversely proportional, right? Nu equal to c over lambda. So change যদি nu to d nu হয়, lambda negative opposite hobo, এই কারণে এটা minus I. It's not important. Etu mod loi just value lole hol. So this, is it clear? 1 over lambda square ইয়ার পর আহিব, right? Derivative lole. So d of 1 over lambda minus 1 over lambda square d lambda, aru ইয়াত amar nu cube or pora eta 1 over lambda cube ahise. So basically total you will get lambda to the power minus 5, right? E to the power this whatever hc by kb by t lambda, so some b by t lambda. So ei gote hc by kb moi b loisu, so b divided by t lambda. So here lambda to the minus 5 is the b by t lambda. This is nothing but ইয়াত এটা constant এতিয়া a boy দিলে, this is our Wien's distribution law. What other law? So Stefan-Boltzmann, this one is easiest. So কি লাগিব? Basically u is total u মনত ৰাখিবা. Stefan-Boltzmann ৰ কাৰণে u lambda নহয়, total u মানে energy density radiated in all wavelength. তাৰ মানে basically integration of u lambda d lambda or u nu d nu, একে কথা. This is u is this u nu d nu hall এটা particular frequency লইছো red, let's say hey red or around কিমান energy radiate হয়, আর টোটাল পাওয়ার হয় red না হয় ব্লু না হয় all wavelength, মানে গোটে এই ফাংশনটোর ইন্টিগ্রেশন এই টু ইউ. সো এই টোটাল এনার্জি or total power on per second calculate koribo lagibo, and that will give us Stefan-Boltzmann law, and we don't need to do this integration. It's much easier than that. So let's say ki ase amar constant, forget about the constants again. Ki ase nu cube ase again, right? So yat kiba eta proportional to nu cube ase, right? d nu pi tolot is h nu by kbt minus 1. This is it, right? So let's say h nu by kbt equal to what? Some x. So all we need here, just look at this, even for simplicity, তুমি exact করলেও হবো, but আমার কি লাগিব, ultimately আমার temperature লাগে, t to the power 4 দেখাবো লাগিব, right? So even you can forget about everything else, just nu over t is proportional to x, এইটু হলে হল, কম্পাইছেন? So anyway, so this, that means what? This will become, so nu cube মানে কি হবো? Nu cube ললে এই পিনে গই t cube x cube হবো. Basically nu cube is x cube times kbt by h cube, right? So basically nu cube is proportional to x cube t cube. এইটো ইম লাগে না লাগে. So nu cube হবো x cube, এটা t cube থাকিব, right? d nu কি হবো? d nu হবো, so ইয়াত nu হল x times kbt by h. So d nu is proportional to again just t dx. Aru constants ebilak na lage, right? d nu will be proportional to t dx. Nu equal to x times something something and t. So d nu is dx aru t to constant. So d nu for ahibo eta t dx. Ar yat ki man ase e to the power x minus 1. Right? Okay. Tar mane t cube aru eta t mili t to the power 4 bahirot ahi gol. And this is just integration x cube dx e to the power x minus 1 from what? 0 to infinity. Karon nu jodi 0 hoy x o 0, nu 0 hole x o 0 hobo, nu infinity hole x o infinity hobo. So limit same hi thakibo 0 to infinity. So what does this mean? Iyat kiba t ase neki? Temperature dependence ekho nai, yeah, just some integration of some x, some function of x, 0 to infinity, integration korar pisot this will be some number 5 6 10 3.5, I don't know, some number, some constant anyway. So this whole thing is just a constant, right? So if it's constant, I can just still say proportional to t to the power 4. I know the constant number. We don't care. Take t nai. So which means u is proportional to t to the power 4, or u equal to some sigma t to the power 4. Sigma is some constant. So this is our Stefan-Boltzmann law. So Stefan-Boltzmann law karone tomar ki koribo lagibo? Planck's distribution law. Just integrate it and don't have to integrate. Just replace all the nu, these h nu by kbt by some x, and then take away all the powers of t outside the integration. And then you will see the integration has no t inside. So which means it's just a constant and you don't care. Just t to the power 4 je bahirot aibo, only that much you have to show. Wien's displacement law. what do we have to show? Where this lambda mt equal to constant. This is Wien's displacement law, right? What is lambda m? Your peak value, your jetia peak hobo energy. What is the corresponding lambda? So this is of course in terms of nu, right? In frequency. So there will be some peak frequency. A peak frequency pi gole c by lambda m kori dem. So if we do this in terms of even frequency, no problem. There is no problem. There will be one slight problem. Let me tell you what is that. Is it তোমার function to আছে? ইয়াত parabolic type হয়. So ইয়াত basically এটা minima আছে. আর তাত এটা maxima আছে. So আমার যে minima maxima condition কেনেকুৱা আমি কৰো? Derivative equal to 0. When we set derivative with respect to, let's say, nu here. Nu is the variable, right? And this is u. So if I do du nu by d nu equal to 0, this does not give us maxima actually. It gives us maxima and minima. Condition for maxima and minima. Why? Because this is slope. Derivative is slope. And slope becomes flat here and here. Right? Slope becomes 0 of a line at this point and this point. So actually this will give you two values. You will see. One is for nu equal to 0. Then of course that is not the maximum condition, right? We know. So we'll ignore that and will give us another value that's the one we'll take. But it's not complicated. Anyway, so u nu is, once again you don't care about the constants. Why you don't care? কারণ last to equal to 0 বহাম. So ইয়াত কিবা কিবি constant front ত আহিলে এইবিলাক পিনে গৈ এনেও 0 হ'ব. So we don't care about this 8 pi by c cube and h here. We don't care. What all we need is dd nu of just nu power, nu function বিলাক. So nu cube আছে ওপৰত এটা আর তলত e to the power h nu by kbt minus 1. That's it. So এই ফাংশনের কারণে even temperature important নহয়. Just a nu is fine. So আরো simplify কৰি দিম কারণ এই তেতিয়া আমাৰ এই constant লৈ এমন ভাবিব না লাগে. So what we do is, let's say h nu by kbt equal to what? Let's say x again. And so nu is proportional to x. On a constant, for now we don't care. So that means d nu is proportional to dx. So in that case, just put nu cube equal to x cube. Aru ki thakibo? Front of constants thakibo, right? Hey, h by kbt cube. We don't care. Karon eneo to 0 hobo yat. Right? Into the 0 hobo. So forget about them. Aru yat kiman hoi jabo? X. But then we have to make this ddx, otherwise it's not very useful. But then see, nu and x are proportional. So basically del nu is just proportional to del. Again we don't care. So this becomes then just del x. On constants ahibo 0 hoi jabo, divide hoy. So del x x cube by e to the power x minus 1 equal to 0. This is the only thing. Etu korile ki ahibo, some expression ahibo, that equal to 0. Expression to ki hobo? Ebar x cube or lower derivative. So 3x square by this minus 1 over denominator square. So this will be 3x square by e to the x minus 1, right? Minus e to the power x minus 1 whole square আর উপর x cube থাকিব, and then derivative of this তলৰ, তারপর e to the x আহিব, and this equal to 0. and then এটা common লই এইপিনে লৈ গৈ simplify অলপ কৰিলে let's see so x square এটা common হ'ব right ইয়াৰ পৰা x square common হ'ব এটা so ইয়াত থাকিব 1 আৰু ইয়াত x গল x divide কৰি দিছো okay because we are considering x not equal to 0 x equal to 0 means frequency equal to 0 not interested in that remember এনেকুৱা divide কৰি ইয়াত x আছে x এইপিনে 0 divide কৰিছো আৰু 0 হৈ গৈছে this is very dangerous let's say something like x into y equal to 0 এই আমি x দি 0 divide কৰি 0 কৰি দিছো very dangerous you should know that this only true when x not equal to 0 নহলে 0 by 0 হৈ যাব so be careful about that so ইয়াতো এনেকুৱা আছে right এইবিলাক কৰি মানুহে proof কৰে 2 equal to 1 3 equal to 5 বিলাক যে মিম থাকে so ইয়াৰ পৰা আহিব x not equal to 0 case only because x equal to 0 means because that means mu not equal to 0 case in that case x bahirot loi ai divide kore den x gol what remains is 3 by e to the power x minus 1 minus x by e to the power x minus 1 whole square equal to 0 once again 1 by e to the power x minus 1 common hobo and 3 minus x by e to the power x minus 1 etu mane moi just algebra kori asu egula tomalokeও koribo pare just it's a problem of find out the maxima of this function right mathematics or problem hs or find out the maxima of this problem for what value of x this is maximum this is that problem okay now once again I say that this thing not equal to 0 if this thing not equal to 0 then this thing not equal to 0 is true it ketia 0 hobo 0 ketia hobo divided by infinity yes x equal to infinity so x equal to infinity hole etu kiman hobo just e to the power x hi thakibo on infinity minus 1 infinity so 1 over infinity only then this is 0 but x equal to infinity is also nonsense we are not considering why karan remember this is your function this is the function that you are calculating the maxima so tomar jana ase maxima kot ase iyat ase 0 to nai infinity to nai you know it physically right x aru nu r majot ene belek difference nai ami nu r function itu aru x ki just constant times nu right h nu by kbt is x so when I say x equal to 0 not interested x equal to infinity not interested we know maxima is not there and we are only looking in this part only in this part and in this part x is not infinity and x is not 0 so again be careful this is not 0 and that's why we can take it in this side divided by 0 divided by this so this is gone so yes so 3 into e to the power x minus 1 equal to x or e to the power x equal to x by 3 plus 1 right so obviously we cannot solve this in a algebraic way kind of quadratic no hoy linear no hoy e to the power x ase ei side of x by 3 ase normally noaru but graphically we can what can we do amar x or value lagibo when I mean the value of x that satisfies this will give us the maxima minima ami agotei cancel kori disu which is x equal to 0 or x equal to infinity we don't care okay so let's see enekwa type equation thakile ami graphically solve korbo how do we solve them this side must be equal to this side So দুটা সাইডৰ কাৰণে বেলেগ বেলেগ বেসিক্যালি দুটা গ্রাফ আঁকি তার কমন পয়েন্ট যেটো only in those points this equation is satisfied. তার মানে হল কি তোমার for example let's draw this. So e to the power x আছে, it's like this, right? E to the power x function eto. This side, on this side x by 3 plus 1. So x equal to 0 to 1 hobo some value, and then body thakibo, right? It will increase with a slope of 1/3. So it will be, I mean, some line like this. So this is what? This is x by 3 plus 1. So this one is x by 3 plus 1 and this one is e to the power x. When do they become equal? That's when our solution happens, right? So ene to independent duta function, but a common point to tahi both become equal, right? Only at this point they both become equal. E to the power x, it was 1. So this is the value of x, that's your solution. It is some value, not important, it is some value. Usually I think it's x equal to 2.8 point something, but exact value is not necessary. So that means only x equal to 2.8 something, because it is for lambda and I'm doing for nu. Okay, so but doesn't matter. They're doing it for lambda and I'm doing it in terms of x, and that's why it will not match. The point is it has to be some value, and that's enough. So x equal to some 2.8 millibo. All you can say is x equal to some number, constant, and that's enough. X equal to some constant. A number means constant. And what was x? X was h nu by kbt equal to constant, right? And that means nu over t is constant. And that means c over lambda is equal to constant. And that means 1 over lambda t is constant. And that means lambda t equal to constant. And what is this lambda? This is the maximum condition. So that's why m like that. So that's your Wien's displacement law.